If you think that the progress with GANs was over, you couldn't be more wrong. Here's BlobGAN, and this new paper is just incredible. BlobGAN allows for unreal manipulation of images made super easily controlling simple blobs. All these small blobs represent an object, and you can move them around, make them bigger, smaller, or even remove them, and it will have the same effect on the object it represents in the image. This is so cool. As the authors shared in their results, you can even create novel images by duplicating blobs, creating unseen images in the dataset like this room with 2 ceiling fans. Correct me if I'm wrong, but I believe it's one of, if not the first paper to make the modification of images as simple as moving blobs around and allowing for edits that were unseen in the training dataset. And you can actually play with this one compared to other companies we all know. They share their code publicly and a collab demo you can try right away. Even more exciting is how BlobGAN works, which we will dive into in a few seconds. To publish an excellent paper like BlobGAN, the researchers needed to run many experiments on multiple machines. Those who played with GANs know how long and painful this process can be. Plus, their code is available on GitHub and Google Colab. This means their code has to be reproducible. Funnily enough, this is also a really strong point of this episode's sponsor, Weights and Biases. Weights and Biases changed my life as a researcher. It tracks everything you need for your code to be reproducible. The hyperparameters, the GitHub commit, hardware usage metrics, and the Python version, leaving you without headaches. Okay, some might still appear because of deadlines or bugs, but none from trying to reproduce experiments. Weights and Biases is also super helpful when sharing your experiment results with your colleagues. A great tool for that is reports. They can act as dashboards for supervisors, PIs, or managers to check how experimentation is going, meaning more time for research while improving your feedback's quality. Please don't be like most researchers who keep their code a secret and try using Weights and Biases with the first link below. Now, let's get back to our paper, BlobGAN Spatially Disentangled Scene Representations. The title says it all. BlobGAN uses blobs to disentangle objects in a scene, meaning that the model learns to associate each blob with a specific object in the scene, like a bed, window, or ceiling fan. Once trained, you can move the blobs and objects around individually, make them bigger or smaller, duplicate them, or even remove them from the picture. Of course, the results are not entirely realistic, but as a great person will say, just imagine the potential of this approach 2 more papers down the line. What's even cooler is that this training occurs in an unsupervised scheme. This means that you do not need every single image example to train it, as you would in supervised learning. A quick example is that supervised training will require you to have all the desired manipulations in your image dataset to teach blobs to learn those transformations. Whereas in unsupervised learning, you do not need this extensive data and the model will learn to achieve this task by itself, associating blobs to objects on its own without explicit labels. We trained the model with a generator and a discriminator in a GAN fashion. I will simply do a quick overview as I've covered GANs in numerous videos before. As always in GANs, the discriminator's responsibility is to train the generator to create realistic images. The most important part of the architecture is the generator, with our blobs and a StyleGAN2-like decoder. I also covered StyleGAN-based generators in other videos if you are curious about how it works, but in short, we first create our blobs. This is done by taking random noise, as in most generator networks, and mapping it into blobs using a first neural network. This will be learned during training. Then, you need to do the impossible. Take this blob representation and create a real image out of it. This is where the GAN magic happens. Since you are still listening, please consider subscribing to the channel and liking the video. It means a lot and supports my work for free. Also, we have a community called Learn AI Together on Discord to learn and exchange with fellow AI enthusiasts. I'm convinced you'll love it there and I will be glad to meet you. We need a StyleGAN-like architecture to create our images from these blobs. Of course, we edit the architecture to take the blobs we just created as inputs instead of the usual random noise. Then, we train our model using the discriminator to learn to generate realistic images. Once we have good enough results, it means our model can take on blob representation instead of noise and generate images. But we still have a problem. how can we disentangle those blobs and make them match objects? Well, this is the beauty of our unsupervised approach. The model will iteratively improve and create realistic results while also learning how to represent these images in the form of a fixed number of blobs. You can see here how blobs are often used to represent the same objects or very similar objects in the scene. Here, you can also see how the same blobs are used to represent either a window or a painting, which makes a lot of sense. Likewise, you can see that light is almost always represented in the fourth blob. Similarly, you can see how blobs are often representing the same regions in the scene, most certainly due to the similarities of images in the dataset used for this experiment. And voila! This is how BlobGAN learns to manipulate scenes using a very intuitive blob representation. I'm excited to see the realism of the results improve, keeping a similar approach. Using such a technique, we could design simple interactive apps to allow designers and anyone to manipulate images easily, which is quite exciting. Of course, this was just an overview of this new paper, and I strongly recommend reading their paper for a better understanding and a lot more detail on their approach, implementation, and tests they did. As I said earlier in the video, they also shared their code publicly in a collab demo you can try right away. All the links are in the description below. Thank you for watching until the end, and I will see you next week with another amazing paper.